Hello there. My name is Daniel Adievich. I work in AppDynamics Professional Services as a solution architect. I'd like to speak to you today about AppDynamics DEXTER. DEXTER stands for Data Extraction and Enhanced Reporting and is a tool that I built to extract configuration, metadata, and performance information from AppDynamics controllers and applications to preserve the snapshot of this activity and to analyze it with various interesting tools. DEXTER works by collecting the data that was previously sent to it by AppDynamics agents. Using a variety of APIs and some compute, it processes the data into sets of CSV files that are then loaded into a variety of visualizations, including Excel, Power BI, and Tableau. Today, I'm going to speak about AppDynamics Metrics Report and how you can use an offline copy of AppDynamics measurements and metrics for your fun and profit. Let's take a look inside of AppDynamics first. On the screen, you should be able to see an AppDynamics flow map within an AppDynamics application performance monitoring application. At the bottom, you can observe a variety of measurements. There's our legend, there's a load, there's a response, and there's an error rate. Those three are typical metrics. Metrics are time series data. They're timestamp accompanied with a variable that measures the value of it. For the call rate, it's the number of calls a minute. For the response time, it's the average response time in milliseconds. For any entity inside of AppDynamics, be it an application or a tier, such as this e-commerce tier, you have a tree of those metrics and then some. For instance, once you drill down into one of the runtimes, in this case a JVM running some sort of e-commerce application, you have a variety of metrics that are available under the memory tab, such as a heap and consumption and garbage collections, etc., and variety of metrics associated with any server infrastructure involved in there, such as CPU and memory and network and process consumption. AppDynamics DEXTER Metrics Report extracts the data from AppDynamics applications and stores them offline so that that data is permanently preserved in the highest granularity possible. Like all other AppDynamics DEXTER reports, this report is an Excel spreadsheet that brings in the data from the CSV file created by AppDynamics DEXTER tool into a single entity, in this case a spreadsheet. Inside of here, we can observe a set of applications that consists of tiers that themselves consist of nodes connecting to a variety of remote services and backends like databases and HTTP web services, observing certain business transactions, in this case shortened to the word BT. We also observe some errors down below and a few other things that are not worth exploring right this second. The AppDynamics DEXTER operated on a certain time range. In this case, this time range is displayed in the front page. It was 8/20/2018. So notice this is looking at the time on my computer. It's actually well in the past. And this covered a couple of hours range in this case, extracting all this data. At this point, the data in AppDynamics controllers would have been rolled up somewhat. Instead of a 1 minute metric granularity, the metrics would be gone and turned into one data point per hour. But not the case in here. So let's take a look at a few of the sheets. For instance, I have a sheet for all the applications. Their performance observed on the right side in columns P through S. Whoops. How about this? We'll draw a square. You can see that this time range covers 120 minutes, and every application is displayed with their core performance metrics: response times, calls per minute, errors per minute. The scatter plot in the upper left area indicates the distribution of the calls versus response, horizontal axis versus vertical axis, and places the applications in relation to their consumption appropriately. If I wanted to, I can actually filter away some. I have two demo environments, and they both have the same kind of applications. Here, by filtering all the uninteresting ones away, I can actually compare performance of applications right there on the scatter plot, calls versus response. And I can see that one of the environments behaving slightly different than another. It has a higher call rate and a slightly slower performance. Let's investigate a little bit further. Let's assume that I want to see the performance of all my components the inside of the given application across the period of 2 time ranges. I would go to the tiers.hourly sheet and filter away all applications but one. So in this case, I would choose the e-commerce applications. How about that? And filter away one of the controllers, because I only care about the Demo 2 controller, and actually filter away the e-commerce fulfillment application. What's left behind is a list of my tiers. Yeah, so here we go. Yeah, in this case, I have 2 rows for every tier that are involved in this time range. The time range I chose incorporated 2 hours. In this case, it was 1 to 2 and 2 to 3. So for every hour, I have a set of data, and every row indicates what happened in that specific hour. So I can compare, for instance, a tier called e-commerce services, and I could see the difference in the behavior between an hour number 1 and hour number 2. One of the hours was slower and faster than the other. The other one was more frequent. No, sorry, slow and faster was not the right way of saying it. One of the hours was less frequent. This transaction was not as frequently used, but it was also faster. Whereas the other hour, the transaction was invoked more times, and it was slightly slower. If I wanted to observe what happened with the specific runtimes, for instance, that happened within this application, I would switch back to the table of contents, navigate to the nodes.hourly, and maybe filter into that applications. Again, I will choose one of the controllers in this case, an application. In this view, see, we'll choose one of these applications called e-commerce and choose one of the nodes. How about the Web 1 node? I can see exactly what that node did within those 2 time ranges and see the behavior, how it happens. If I scroll a little further to the right to the column AB, I can click on the metrics link for one of those nodes and open up an offline copy of all the metrics that were associated with this specific node. Let's take a look at them all. We have information about the calls and response. Here we have 2 hours, hour number 1 highlighted on the screen, and hour number 2 kind of back to back. The more hours you add to your time range, the more of these metric graphs you will have. As you go through the rest of the sheets, you can observe the CPU usage has been preserved. We can have an OS disk consumption, the network. In this case, I don't think it was captured at the time. These are not .NET nodes, so the CLR sheets are going to be empty. But for JVM process, we're going to observe the memory and heap. Everything that you actually see inside of AppDynamics has been taken out and preserved for your investigation pleasure. I hope that you find these 2 reports very handy to use when you need to preserve your metrics offline and then analyze them for either root cause analysis or comparing the incident in one time to another one. Thank you for listening.